Have you ever found yourself confused about whether a const reference is prolonging the life of a temporary object? It can be a tricky concept to grasp, but don't worry, you're not alone. Today, we're diving into this question and breaking it down step by step. I totally understand how frustrating it can be to deal with references and lifetimes in C++. It's a common concern among developers, especially when working with temporary objects. You're definitely not the only one who has faced this challenge. Let's take a closer look at the specific question at hand. One user asked, does my const stead string reference prolong the lifetime of the temporary stead string function argument created in the call to get or do I have a dangling reference? This is a great question and one that many developers encounter. To understand this, we need to clarify what a local const reference is. In C++, only local const references can extend the lifespan of temporary objects. If your reference is not local, it could lead to a dangling reference, which is something we definitely want to avoid. Stay with me, because by the end of this video, you'll have a clear understanding of how to manage const references and avoid dangling references in your code. To determine if the user has a dangling reference, we first need to understand the context of the function. The user has a function called getOr that returns a const reference to a string. Next, we need to analyze the return value of the getOr function. It returns either a reference to the optional string or the provided default string. Now let's focus on the main function. The user creates a const reference foo that captures the return value of getOr. If str is not initialized, foo will reference a temporary string. Finally, if str is not initialized, foo will indeed be a dangling reference. To avoid this, the user should ensure that str is initialized before calling getOr. Fun fact, did you know that C++ was originally designed to enhance the C programming language with object-oriented features? It's come a long way since then, but some of these complex concepts still trip us up. Now, let's look at the answers provided by other users. This user clarifies that a const reference does not extend the lifetime of a temporary object in the given situation. They provide an example where a temporary object is created and then printed, but it gets destroyed before the print function is called, leading to undefined behavior. They also show a different scenario where a temporary is directly bound to a const reference. In this case, the object remains alive until the end of its scope, allowing it to be used safely. That's all on that answer. Let's take a look at another one. The user points out that the string passed as the default parameter in the getOr function does extend its lifetime, but only until the end of the function call. However, when you bind that return value to foo, it does not prolong the lifetime any further. As a result, the string is no longer valid by the time you try to print it. Let's take a look at an answer from another user. The user explains that the temporary stead string created when calling getOr does not have its lifetime extended. When you return a reference to this temporary, it will be destroyed at the end of the getOr function, leading to a dangling reference. They illustrate this with a custom string class, showing that the destructor is called before you can use the reference. In contrast, if you directly assign a reference to a temporary, its lifetime lasts until the end of the main function. This allows you to use the reference safely within main. Here's a pro tip. Always initialize your member variables and classes to avoid unexpected behavior. This simple practice can save you a lot of headaches down the line. And there you have it. You now know how to handle const references and avoid dangling references in your code. If you found this video helpful, please hit the subscribe button for more programming tips and tricks. Keep coding confidently.